An application of dot product is a physics process called work. And I can't help but think of that song. It goes, it's kind of always something like work, 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 work. So we're going to talk about work, 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 work. And the definition of work, as we are referring to it in the physics sense of the word, we have D is the displacement. Now, displacement is how much it moves. We've heard the word displacement before when we were talking about simple harmonic motion. Think about that block moving along the spring. So if D is the displacement of is the displacement vector, I should say, so notice it's a vector, of an object, in moving the object in a straight line from point A to point B under a constant force F, so F is a vector, that's the force vector. D is a vector, it's the displacement vector. Well, the work done is computed by finding the dot product of the force vector and the displacement vector. Okay, so let's look at a few examples. Computing work, this is example 6 from your textbook. Find the work done by a force of 4I plus 9J newtons, so force is often in newtons, in moving an object in a straight line from point A, which is at 1,3, to point B, which is at 4,8. Assume that the units in the coordinate plane are in meters. Okay, so we've got clearly a force vector, and we've got it in IJ form. Okay. Now, we have some information about displacement, but excuse me, we would like that to be in a form of a more computational friendly form. So we want it to have an initial point at 0, 0. We want it to be in standard position. So we're going to rewrite this into standard position, and I'm going to call it D for the distance vector. That's going to be 4 minus 8, 4 minus 1, and then 8 minus 3. And the distance vector then is going to be 3, 5. Now, it's nice to be consistent, so let's put this in IJ form, 3I plus 5J. Okay, so there's our distance vector. Well, work is the dot product of the force vector and the displacement vector. So we know this is a scalar quantity, meaning it's just a constant. So 4 times 3, we multiply the horizontal components together, plus 9 times 5, and that's 12 plus 45, which is 57. Our force was in newtons. Our distance, or our displacement, sorry, I keep calling it the wrong thing, was in meters. So that's 57 Newton meters. All right. A Newton meter is also referred to as a joule, Joule. Some of you physics people may be more familiar with that. So 57 Newton meters, otherwise known as 57 joules. All right. Let's take a look at another example. Very similar. So we've got our force vector is in IJ form, 2 vector I plus 7 vector J. We need to write our displacement vector in standard position. So to do that, we will say 9 minus -1, 11 minus 5, and we get 10, 6. Putting that in IJ form, 10 vector I plus 6 vector J. Work is the dot product of those two, so work is equal to the dot product of the force vector and the displacement vector. So we have 2 times 10 plus 7 times 6, 20 plus 42, 62 Newton meters, or 62 joules.